Welcome to another exciting edition of Pre-Calculus, even and odd functions. Yeah, let's go. All right, even functions. This hopefully is not going to be that long of a video, but I don't know. You never know. It depends on how much I like to talk. Even functions. So these are basically going to be symmetric, okay? And what that means is if they're symmetric about the y-axis. About y-axis. There we go. So what that means is if I have my y-axis down here, that's a terrible y-axis, and so on. If I were to fold them in half, one side versus the other, it would literally land on the same thing. So if I folded this here, and then this would transpose over here, boom, there we go. This is then this, and then this little piece here would then be that little piece there. Even functions are symmetric about the y-axis. They have to be, okay? That's why they're even functions. What about odd functions, you might ask? Well, I'm here to tell you that they do not. They are not symmetric over the y-axis, but they are symmetric if you rotate them 180 degrees, okay? So these are not symmetric, I can't spell today for some reason. Symmetric about y-axis, but it's called rotational symmetry. Rotational symmetry. What I mean by that is this. If I take this linear function, right, this is y equals x, and I take this piece here, but I rotate it 180 degrees, I will then get that other piece. The same thing here. If I take this is y equals x cubed, and I rotate it, either rotate it this way or this way, or it's 180 degrees, so it doesn't matter how I rotate it. Okay, so let me do something a little different here. So then if I rotated it 90 degrees, so this y equals x squared, if I rotated it 90 degrees, then I would get something like this. If I rotated it 180 degrees, then I would get the other piece. If I rotated it 207 degrees, then I would get that. That's kind of cool, like a little, I don't know what that is. Maybe like a ninja throwing star or something like that. It's kind of cool. And then this one here is y equals, this is sine of x, right? So sine of x is an odd function, where the one above it here is actually y equals cosine of x. So cosine is even, but sine, can't spell either, is odd. Okay? So again, 180 degree rotation would be, boom, right there. Okay? Cool beans. What about the graph? So graphically, we talked about the even and odds, but if I look at these now, what are these, even or odd? So these kind of graphs are really weird, but these are actual functions. Okay? So if I take my y-axis and I split it so that I fold it in half, I can see that this point is going to match up with this point, and this point here is going to match up with this point, and this point is going to be over here, and this point over here, and because that happens, this is an even function. It is symmetric about the y-axis. If I look at this one, I'll see that what? Well, it's basically nothing's going to happen. This point is not over here. Okay, it's not symmetric that way. So what if I were to rotate it? That means this point would actually be like up here, and this point that's here would actually be down over here. Okay, you can see hopefully the rotation, and this is neither. There is no symmetric, there's no even odd functions on this one here. Okay, now let's look at this one. If I have this piece here, when I rotate it 180 degrees, I'm going to get this one. If I have this point up here, the top piece there, when I rotate that 180 degrees, I'm going to get this one down here. So because I can keep doing that, this is the odd function. Odd. It's odd. It's rather odd. All right, so here's how I can draw an even and an odd function from half of a graph or whatever the graph is that I have here. Okay, so even function basically says that any point that I have, okay, any like min max or whatever you want to call it, really any point, okay, even this one here, well, and that one there too, I guess. No, and that one there too. So there's 5 right there. It will you can flip it, okay? So you can symmetrically put it about the y-axis. So this point here is probably going to be right in there. This point up here is going to be over here. Okay, it's in the same spot, it's just flipped. This point here is going to be right around there. Then we're cooking with gas, and we're going to go right in there. And then now we're going to go right in there. So you can see that if I went through, ooh, my graphs are terrible. Holy cow, that's awful. Let's see if I can fix this again. Okay, that's not that bad, but that's still pretty bad. But you can see the symmetric properties it has, okay? In odd function, what happens is if I look at the points, I'm actually going to rotate them 180 degrees. So if I look at this one here, this is actually -1, okay, -1, 1, 2, 3, which is -1, comma, -3. But when I flip that 180 degrees, this quadrant, if I think about this, is really negative, negative in terms of x, y values. When 180 degree rotation is, this is now positive, positive. So -1, -3 turns into 1, +3. All right, this one is -2, -2.5 or whatever, comma 1. So when I rotate that, it's now +2.5, comma, -1. Okay, and that's how you're going to work on these ones here. So this one is going to go up, come back down. It's a terrible down. Hold on, let me fix this. Boom, boom, boom. Okay, there we go there. So that's our symmetric function of rotational symmetry, right? So it has rotational symmetry. Now, even in odd functions, so that we have the graph, we have all that awesome stuff, and now we're going to get more into the point aspect behind it. Okay, so if I look at the even function, I'm going to kind of do some work with numbers here for points. So this is -1, 2. This is +1, 2. This is -1, 2.5, we'll say, comma, -2. And that means this is going to be +2.5, comma, -2. But now if we talk about it in terms of variables, this part here, what do we notice the difference between them? That the x's are flipped, right? So every y value is the same, but the x's are flipped. So this point here is really -x, comma, f of -x, right? Remember, every point we have is x, comma, y, but it's really x, comma, f of x. That's another way we can write it. And we're going to use this, it's called functional notation, okay? So it's a -x, comma, f of x. Well, if this is a -x, that means this here is a +x, comma, f of +x. So what does that mean? Well, when x is 1, so when x equals 1, if I plug it into these pieces here, this gives me -1, comma, when I plugged the -1 in, I got +2. When I plugged +1 in, I got +2. So they're the same, so they're able to be used that way. Therefore, f of -1, when I plugged it into the function, is the same as f of +1. And that's a property of even graphs, okay, even functions. The negative of the x is equal to the positive of that x. So how do we do this with actual function notation? Well, it's the f of the -x is equal to the f of the +x. This is what we care about. When we are going to be asked to see if these functions are odd or even, and we have to find them out algebraically, this is what we're going to use, okay, for even functions. Now for odd functions, okay, what actually is going on? Well, this part here is actually -x, comma, f of -x, okay? So this point here is actually -x, comma, f of -x. But this one up here is I'm sorry, there we go, is actually x, comma, f of -x. So what happens? Well, if x is 1, I am going to get, so if I plug in here, if x is 1, that means I get -1, comma. If I plug in -1, I get -3. Okay? But up here, if I plug in 1, I get 1, comma, +3. So you'll notice now both of my numbers changed. My x's changed and my y's changed. Where here, only my x's changed. Okay, so it's going to be a little different. So what happens is that since f of -1 equals -3 and f of 1 equals +3, in order to determine that these are odd or rotational symmetry, then the f of the -x piece has to equal f of x. Well, f of -x is -3, but f of x is +3. So how do I make these equal? Well, I put the negative right there. Okay, so now whatever I get for f of x, which would be 3, I turn it negative. Okay, so this here is going to be used for algebraic representation, how we can prove it algebraically. Okay, let's go on to some problems here. All right, how are these functions? Odd, even, or neither. We got to prove them. And how do we prove them? Well, that's what we just talked about. So we use our algebraic function property from above, whether it be the even or the odd thing that we just talked about. And we're going to prove them. So algebraically, remember for even, okay, it was f of -x is equal to f of x. For odd, that's weird, I was saying odd that way. It's f of -x equals -f of x. And then neither means they just wouldn't work out either way. So here's what I got to do. I really have to, and really all in seriousness, you have to kind of guess. So if I have my even and my odd, I kind of am looking at my functions and I'm going to say, well, since this 3 is odd, I'm going to maybe see if this whole function is odd. So let's see if it's odd. Okay, so how do I do that? Well, I'm going to take the -x in the f part and the -f of x, and I'm going to plug them in to see if they equal each other. So how do I do that? Well, I'm going to say, okay, f of -x is equal to -2 times. All I'm going to do is plug in -x into wherever x was up here. So -x to the third power plus 5 times -x. Find out what this equals. Well, -x to the third is really -x, okay? That's still -x to the third. So that's going to be a +2x to the third, okay? Negative to the third power, so negative. Plus 5 to the 5 times -x, which is really, this is really minus 5x, okay? So this is just 2x to the third minus 5x. So that's what f of -x equals. Now I'm going to see what -f of x equals. Well, if it's -f of x, I'm just taking the original function and I'm putting a negative in front of it. So -2x to the third plus 5x. So when I distribute, I get positive 2x to the third minus 5x. So are these two pieces the same? And they are equal, therefore this function is odd. Okay, that is how you prove it. Let's go to the second one here. X squared plus 1 over the absolute value of x. Well, I'm going to look and say, because this 2 is even, I'm going to guess and see maybe it's even. Okay, so let's go to the even piece. So this is f of -x equals, again, I'm going to plug in -x into everything here and see if it equals the other side of the equation. So if I plug in a -x squared plus 1 over the absolute value of -x, that's equal to -x squared is just x squared plus 1. Well, the absolute value of x is just the absolute value of x. Okay, so that's pretty easy because the negative, right, doesn't really matter because when it pops out, it's still positive. Okay, so I'm actually going to get rid of those bars on the bottom. So there we go. So I got rid of the absolute value bars because the absolute value of a negative is positive. So then this has to equal f of positive x. So that's just x squared plus 1 over the absolute value of x, which is x squared plus 1 over the absolute value of x is just x. Since these two are equal, this is an even function. Okay, it is an even function. Fantastic. We got one more to go, and then this video be done, son. I'm rhyming. Well, now you might be wondering, what happens about neither function? So I'm going to guess you're going to be like, well, this is probably a neither function. Well, yeah, it is a neither function, but how do I know that? Well, there really is no easy way to figure out. You have to do both ways. You have to see if it's odd, see if it's even, and then if it's not, then it's neither. So let's see if, I'm going to do half here. Let's see if it's odd first. So that means it's f of negative x is equal to negative f of x. Okay, let's plug in this piece here first. So f of negative x equals, now it's negative x to the 4 over negative x to the third minus 1, which is equal to negative x to the fourth, because that's negative to a fourth power, that's positive x to the 4. Negative x to the 3 is still negative x to the 3, because that's what happens when I have a negative to an odd power, minus 1. So that is what the f of negative x stands for. Now let's go f of x with a negative out front. Equals, so that's the original function, okay, x to the 4 over x to the 3 minus 1 with a negative out front. Now, if you remember from years ago with fractions, if I have negative 1/2, remember that negative can go in my numerator, or it can go in my denominator, and it can be the same thing. Okay, so I can put this negative wherever I want. Well, if I looked up top, it doesn't go up top because that's positive, so I'm going to put it down to the bottom. When I do that, I'm going to distribute that negative through, so that gives me negative x to the third plus 1. That's different than a negative 1, so these two are not equal, therefore it's not odd. So now let's do the even. So this is f of negative x is equal to f of x. So let's do it. Well, let's save your guys some time, because really, if I got f of negative x, well, didn't I already do that over here? So f of negative x is equal to x to the 4 over negative x3 minus 1, or negative x to the third. Oof, that was bad vocabulary there. So f of x, the regular one, is just the original function again. So x to the third minus 1. So you can see that now this one is negative and this one's positive. So that's why they are not equal. So therefore, this is a neither function. It doesn't have rotational symmetry, and it doesn't have reflective symmetry, is what the even functions have. Okay? Fantastic. This concludes this video. Hopefully it wasn't too bad. But it wasn't too long either, hopefully. And good luck. Ask questions if you need any help. And deuces.